So for this, we're going to end up graphing f of theta equals tangent theta. This is to get an idea of what the parent function of tangent looks like so that we can apply transformations to it. So to graph tangent theta, we just need to graph one period, and then we could just keep copying over the period over and over since tangent is a periodic function. It'll just keep repeating itself for an indefinite amount of time going to positive and to negative infinity. So we're just going to graph from negative pi over 2 to pi over 2. You might notice this is different from when we graphed sine and cosine, because sine and cosine were from 0 to 2 pi. That's where one period lied for each of them. For tangent, it's from negative pi over 2 to pi over 2, because these two values, when you plug them into tangent, are undefined, which means that there are vertical asymptotes at each of these values. From here, it just helps to get a few more values to get an idea of what this graph will look like. So what I like to do is just take the midpoint of negative pi over 2 and pi over 2, which would be 0, and then the midpoint of negative pi over 2 and 0, which would be negative pi over 4, and the midpoint of 0 and pi over 2, which is pi over 4. These are not all quadrantal angles like we had with sine and cosine, but these are all unit circle values. So when we plug in negative pi over 4 into tangent, we get negative 1. When we plug in 0, we get 0. And pi over 4, we get positive 1. And this gives us enough information to know what the graph of tangent will look like. We have a value at negative pi over 2 and positive pi over 2. Then at negative pi over 4 and positive pi over 4. And finally 0, which is just the origin. At negative pi over 2 and positive pi over 2, there are vertical asymptotes, which are just these dotted lines. At negative pi over 4, we have a y value of negative 1. So I'm just going to list that this graph is going from negative 5 to 5. And at negative pi over 4, we'll go to negative 1. 0, we have a y value of 0. And pi over 4, a y value of 1. Which when we connect these dots, remember, these are not going to be pointy-edged graphs. They're going to follow a curve. So this is not just going to be a straight line. It's going to follow a curve to it like so. And then from here, remember when you have a vertical asymptote, your graph is going to kind of bend and rapidly approach it, which means it's going to look something like this. I like to think of it almost like the graph of x cubed. While they are not the same values, they have the same shape between two vertical asymptotes. And if we wanted a second or third or fourth period of tangent, all we'd have to do is keep adding on another vertical asymptote, a distance of pi away because the period of tangent is pi. Negative pi over 2 to pi over 2 is a distance of pi. So just keep adding a vertical asymptote a distance of pi away to the right and to the left, and just keep redrawing this same shape over and over and over again, and we get our graph of tangent of theta.